g prime of x being undefined. So can anyone give us g prime? Since everything hinges on g prime, so let's find g prime right away. Can anyone give us g prime of x for this function?
3x squared minus 12.
Thank you very much. Good. One thing I know for sure, which of these two sources will be a waste of time to investigate?
The first one.
This can never be undefined. This is a polynomial function. G prime will always exist. Give me any x. 0, I'll say negative 12. 1, I'll say negative 9. 5, I'll calculate and give you the number. So this function is a polynomial. It exists everywhere. This would be a waste of time to even talk about it. The other one, though, I have to solve the equation, set it equal to 0. How many solutions will I get? Before I even attempt to solve it.
2.
Exactly. Thank you. That's all I want you to say. It's a quadratic function. Quadratic equation, we have to find two solutions. First, I will always divide and simplify and clean it up. So I have x squared minus 4 equals 0. How do you want to solve this? We can factor, we can take square roots. What would you like?
Just factor x minus 2x plus 2.
Excellent. So we have x equals 2 and x equals negative 2. These are the so-called critical numbers of g of x. Are they max min? I have no clue. In the next step, I have to investigate. So if it didn't have critical numbers, I would have said, sorry, this function has no max min. Goodbye. But we did find critical numbers. In part B, they're saying, okay, if you do find critical numbers, tell us whether they are max min or none of the above. So here is my next step. How do I investigate? I will write it here. By studying the sign of g prime of x. This is how I'm going to investigate. And you can say, how are you going to do that? And here it is. Please work with me and try to understand this table. It will save a lot of time later on. Okay. X, g prime of x, and g of x. X is the variable in the problem. Can anyone give us the domain of this function?
Negative infinity to positive infinity?
Absolutely. It's a polynomial function. There is no discussion there. It was just a trick question. Sorry about that. All I care about is negative 2 and 2 in the correct order in the table, from left to right. For g prime, what do I write under negative 2 and under 2 for g prime? What does it equal to at negative 2 and 2?
0.
Of course. That was another tricky question. Good. Excellent. So now I'm going to copy it here so I can move this away. So I'm copying here g prime of x as 3x squared minus 12. Okay. Perfect. In this function, pick a number here, any number you want between negative infinity and negative 2, and tell me the sign of this expression. I don't need any number. You plug in any number and you tell me the sign here. Then you can plug in 0 in here and tell me the sign. And you can plug in 10 and tell me the sign. No number, just the sign.
Negative.
On this side.
Yeah.
So let's plug in.
It's gonna be positive.
Right, because negative 10 squared is positive 100. Positive 100 times 3 is 300 minus 12 is positive. Careful because this is squared. So if you plug in 0, which sign will you give?
Negative.
And here?
Positive.
Excellent. Don't draw any conclusions yet. We have to find the y value for negative 2, and we have to find the y value for 2. I'm going to copy the function here so I don't have to go back to, so it was x cubed minus 12x and plus 5. And I'm going to share my screen and put it in the graphing calculator. Where is my calculator? Here. Of course, you know me, I prefer the y equals. Okay, and I have x cubed. I will leave that without parentheses just this time. And then plus 5. And then second in table, I'm plugging in negative 2. And I'm plugging in 2. I need these numbers. So the first one is 21. And the other one is negative 11. I put them in the table where they belong. And now I only have to draw a conclusion. The derivative is 0 at this point. And look how it changes sign. What does this mean? When the first derivative is positive, what does the function do?
Increasing.
Excellent. And the first derivative is negative, what does the function do? Good. And when the first derivative is positive, what does the function do? Okay, so now let's analyze what this point is. What point is negative 221?
Local max.
Absolutely, local or relative max. So negative 2 comma 21, local or relative, whichever you prefer, max. Awesome. So what have we established? Let me go back for a second to the other pages. This is what we established, that the first derivative is 0, and it changes sign from positive to negative. Therefore, this is a local or relative max. Awesome. Now let's identify what's happening here. What type of point is 2 comma negative 11?
Local min.
Local min. So 2 or negative comma negative 11, local. I'm writing both because you may encounter both, so I don't want you to get confused. Relative min. Why is that? Because it was exactly the other pattern. The first derivative was 0, and it changes sign. It changed sign from negative to positive. So that's a local or a relative min. So yes, the function has a relative max and a relative min, local max, local min, and we answer the problem. So number 1 was asking us, does it have critical numbers? Yes, we did find 2 critical numbers, not from this source, but only from this one. Then we were happy. Okay, are they max min? I have no clue. Not until I studied the sign of the derivative. I did study the sign of the derivative in this table, where I have the x values, I have the first derivative, and then the function. Now, you don't need to do this. I'd like to move on and just say local max or relative max and local min. That's good enough. But for at the beginning, I'm just going to write them on the side so you understand what's happening. Any questions on this? Any questions on how to find critical numbers and how to determine whether they are max-min. They don't have to be, but it happens that the derivative change is signed this way, which is a max. That's why I put these arrows. And it's a min. That's why I put these arrows, because it's from negative to positive. Negative slope and then positive slope. Okay. Of course, anything else will be different. These are rational exponents. This is another polynomial. This is exponential function, and this is log. Do not sketch the graph yet. So I'm going to assign a couple of problems from this section. Do not. So please skip the sketching. We're not ready to sketch yet. We have a long way to go before we do that. So, but we can determine increasing, decreasing. So yeah, one other thing here. Can we say where is this function increasing? Yes. Between negative infinity and negative 2, union 2 to infinity. I'm going to write that down. So f increasing on negative infinity, negative 2, union to infinity. No brackets. This is just the tendency, okay? And the function is decreasing on negative 2, 2. This is what the first derivative is telling us about the function. Two things. Increasing between negative infinity and negative 2. Union, increasing between 2 and infinity. And it's decreasing between negative 2 and 2. It has a local max, negative 2, 21, and the local min 2, negative 11. Okay, let's practice another and then look at a word problem. You choose. Do not sketch. No, please do not sketch. We cannot do that just yet. We will. What makes an x value a critical value? Okay, so this is a critical value because the first derivative is 0. This is not a critical number. This is a critical number because the first derivative is 0. This is a critical number because it's a cusp. The derivative does not exist at that point. So it's coming from the function prime not existing. This is a critical number. It's a local max or relative max. Same thing. Minimum. Same thing. The same with this one. The derivative is undefined, but the function is continuous. So it has a relative or a local max here. Same thing here. It's also absolute for this. It's smallest possible. And nothing here. This is not a critical number. And this is a critical number, which is a max. Okay. So would you like to choose another problem to go through the extrema, critical numbers, and find max min if they exist?
64.
Which one? 54? This one?
64.
Ah, 64. 64. Okay, very good. So let's take a look at 64. So we have g of x equals natural log of x squared plus 4x plus 7. Perfect. Thank you. Very good choice. Exactly the same steps. In step 1, I have to find g prime. And after I find g prime, I will try part A to solve the equation, and part B to see if g prime of x is undefined, where the function exists. Because if it's undefined and the function is undefined, then that's not a critical number. Okay, so since both of them involve g prime, let's find g prime. Can anyone give us g prime? Anyone remembers how to differentiate log of a function, natural log of a function? Anyone?
I could try it.
Yes,
Is it 2x plus 4
yes,
over x squared plus
yes,
plus 7?
yes. So 1 over the function times the function prime. So I agree with 2x plus 4 at the top. Awesome. So 1 over the function times the function prime, which is 2x plus 4. Good. Now, let's look at the first source and then the second one. Can this function be undefined? Yes, as long as this can be 0. I don't know. We'll see in a moment if it can. But we have to investigate both avenues. So here it is. First avenue, part A, g prime of x equals 0. Can anyone tell us what to write after I write? Let me write this first. When is a fraction 0? This is from algebra. When is a fraction 0?
When it's multiplied by 0.
Yes, when the numerator is 0. So this implies 2x plus 4 equals 0. We move 4 divided by 2. How much is x?
2. -2.
Very good. So we found the critical number guaranteed. Will this be a max min? I have no clue. I have not investigated anything yet. I have to look at the second possibility. When g prime of x is undefined. When is this fraction undefined? When will 2x plus 4 over x squared plus 4x plus 7 be undefined? In which possibility, which situation?
Denominator equals 0.
Excellent. Only when x squared plus 4x plus 7 equals 0.